Welcome class to this video called Unit 7 Practice Quiz Graphing Quadratic Relations. This will serve as a review for the quiz, which is fast approaching. I'm going to walk you through it step by step, and you should be very well prepared by the end. Alright, so the first thing we're going to do is we're going to take a look at this parabola that you can see on the screen here, and we're going to label its important parts. The first part we're going to label is A, which is pointing to the axis of symmetry. And the axis of symmetry is a line that splits the parabola directly into two pieces, two congruent sides. And if you were to fold the parabola along the axis of symmetry, these sides would match exactly. Okay? And whenever we're writing down the axis of symmetry, we always write it as an equation x equals, and the equals is the value of x where the axis of symmetry is written. So in this case it would be x equals -1, because according to this right here, the x value at the axis of symmetry is -1. B wants us to identify symmetrical points. And what are symmetrical points? Symmetrical points are points that match. Okay? Now, when we think of them as matching, they are going to have the same y value. So if you notice here, they have the same y value. Their y values of those 2 points are both 0. And the other important characteristic about symmetrical points is that they are an equal distance from the axis of symmetry. So these are points that have the same y value, and we can write a little note here: same y values and equal distance from the axis of symmetry. All right, now we can look at C. In C, it is pointing to what we call the vertex. The vertex. Okay, and the vertex is going to be either the highest or lowest point of the parabola. Okay, so you're always looking for that highest or lowest point of the parabola. That's your vertex. D is pointing to, if you recall, this line here is called your y-axis, and D is pointing to the y-intercept. Alright, so that handles the parabola that you can see there. Let's look at some of these questions here. What is the form of a quadratic equation? The form of a quadratic equation is as follows: y equals ax squared plus bx plus c. That is the form of the quadratic equation. What is the form of a quadratic equation if b is equal to 0? Well, I'll show you the work over here, and then we can write down the answer. We made b equal to 0. What would 0 times x be? It would be 0, so ax squared plus c is our answer. Y equals ax squared plus c. What is the form of a quadratic equation if b and c equal 0? So now think about it. We decided to make this equal to 0 as well. What are we left with? We're left with y equals to ax squared. Looking at the next questions, which are true and false questions. Number 5 says, determine which of the following statements are true or false. A is, all parabolas are symmetric. This is definitely true. This means that you will never have, for example, a parabola that is like this, for example, right? That is not symmetric. If I divide it in half, I do not get two sides that are exactly the same. Every parabola will be divisible into two halves that will be exactly the same. So they are all symmetric. Zeros are also called y-intercepts. This is patently false because zeros are actually x-intercepts. Okay? We don't call y-intercepts zeros, so this is false. A parabola could have no x-intercepts. Well, I want you to think about it. You can see this parabola that I drew here had x-intercepts, but what if the parabola was like this? Would it have any x-intercepts? Or like this, would it have any x-intercepts? The answer is no. So a parabola could have no x-intercepts. That is true. A parabola has a maximum when it is facing up. So facing up is this parabola that you can see there. Does it have a maximum value or a minimum value? It has a minimum value. Therefore, a parabola has a maximum when it is facing up is false. It has a minimum value when it's facing up. A parabola can have two y-intercepts. So the kinds of parabolas that we're working with, the answer is false. Okay. Question number 6 says, fill in the empty spaces of the chart below. In this chart, we are going to be looking at 4 different equations. We're going to identify them as either linear, quadratic, or neither. We're going to identify their vertex. If there is no vertex because it is not a quadratic equation, then we will put NA. If it is a quadratic equation but we do not know how to determine the vertex, then we can put CD. If we know the vertex, naturally we put the coordinates of that point. Then we have to write if it opens up or down, or not applicable if it is not a quadratic equation. So we have the relation a equals b squared, the relation equation, same thing here. Is that quadratic? Well, it's a second degree equation, and all second degree equations are quadratic, and by second degree equations we mean they have an exponent of 2. And very good. Now this is an equation that is in the form y equals ax squared. And so when we have that kind of quadratic equation, we know the vertex is 0, 0. And we need to determine if it opens up or down. Now the coefficient of x squared, or b squared in this case, is positive, and therefore it opens up. Okay, and so if I were to actually graph that equation, it would look something like this. All right, the next one is c equals 50n plus 2000. This is a first degree equation, and therefore it is linear. By first degree equation, I mean the highest exponent is 1. There is no vertex, and so I will put not applicable. It does not open up or down because it's not a quadratic equation, it's not a parabola. D equals negative 9p squared plus 12. In this, we have a second degree equation. The highest exponent is 2, and therefore it is quadratic. Now this is in the form y equals ax squared plus c, and therefore the vertex is going to be 0, 12, right? Because when you have it in that form, it's 0, whatever the value of c is. C has a value of 12. Does it open up or down? Well, it is, a is negative. This value here is negative, and therefore it opens down. How about y equals 7x to the power 3 minus 5x plus 12? Well, this is a third degree equation. The highest exponent is 3, and therefore it's neither linear or quadratic. And there is no vertex. And we do not need to say if it opens up or down. Now we can do question number 7, which says fill in the empty spaces in the chart below. So in this we have quadratic y equals negative 0.5 x squared minus 9. A is 0.5. It is negative, and that means that it faces down. C is negative 9. And this means that it pushes down 9. Pushes down 9. So we can put push, or we can just write down. All right. And then what is our vertex? Our vertex for this equation This equation is in the form y equals ax squared plus c, and so our vertex is going to be 0, -9, because it's in the form 0. When you have an equation y equals ax squared plus c, then the vertex is always 0, c. All right, and then max or min. So remember, this is facing down, which means it's going to have a max. And what is that max value going to be? It's going to be -9. Okay, that's going to be the highest y value. The next equation is y equals 10x squared. A is 10, it's positive 10, and therefore this quadratic faces up. C is 0. There is no push up or push down. The vertex is going to be 0, 0. The max or min is going to be a min, because this is going to be an equation that is going to be quite thin, probably thinner than that. I guess depends on the scale of your x-axis, but it's going to be quite thin, and it's going to open up, and it's going to have a minimum, and your vertex, or your minimum value is going to be 0. Your vertex is 0, 0, and your minimum is 0. All right, so now if we look at y equals -x squared minus 2, a is -1, it's negative, so it's down. C is -2. That means the graph is going to be lower on the y-axis, and so it's being pushed down. And the vertex is going to be 0, -2. And since this is opening downward, you're going to have a max, and that max is going to be the value -2. All right, so it would be an equation that looks something like that. All right, so then y equals 2x squared plus 11. A is 2, it's positive 2, so it opens up. C is 11, it's positive 11, so it's pushed up. The vertex is going to be 0, 11. The max or min, well, when it's facing up, it has a min. And the min value is going to be 11. And you could think of this graph as looking something like this, where this would be 11, okay? And it would be thinner than x squared. Question number 8 says fill in the empty spaces in the chart below. We're looking at a quadratic relation, and we're going to determine, can we find the y-intercepts or the zeros from the quadratic relation, and then we're going to write the actual points. So y equals x plus 7 times x plus 5 is showing us the zeros. All we have to do is write the opposite sign. So if it's plus 7, then our 1 0 is going to be, here we're going to write zeros. But if it's plus 7, then one of our zeros is going to be -7, 0, because it's the opposite sign. So positive 7 is -7, and the other one is going to be -5, 0. And in the previous video I showed you how that works, but I'll just explain it again. If you recall, when you go to the x-intercept on a graph, the value of y is always 0. And so if I were to put here 0 equals to x plus 7 times x plus 5, right, what this would mean is that either this value or this value have to be equal to 0. So there's going to be two ways that this statement could be true. Either this is 0 or it becomes 0. Well, how could I make x plus 7 0? Let's look at it. 0 equals to x plus 7. I would do basic algebra, which means I have to subtract 7 from both sides, and x is equal to -7, which is the answer that we put here. What about for this one? How could I make that one 0? How could x plus 5, what would x have to be in order for x plus 5 be equal to 0? It would be, I'd subtract 5 from both sides, and then I would get x equals to -5. Okay, so that's the math behind what we're doing, but you simply can look at it and say, hey, I know x plus 5 is going to be the opposite, going to be -5. X plus 7 is going to be opposite, going to be -7. All right, now looking at y equals 5x times x minus 1. Again, we're in this case, we are given the zeros. And how can we find the zeros? Well, imagine what would we have to do? Let's look at it like this. 5x times x minus 5. What would x have to be equal to for 5x to be equal to 0? X would have to be equal to 0, right? And you could find that by dividing both sides by 5, and then what do we get? X is equal to 0. So that's going to be one of our zeros is going to be 0, 0. And then the other one, what would x have to be if x minus 1 is going to be equal to 0? And then it would be 0 plus 1 is equal to x. X is equal to 1. And so we get 1, 0. Now this third one here, y equals x squared plus 5x plus 6, is showing us the y-intercept. And so the y-intercept is going to be 0, 6. Okay, and then we get that by, if we say, what do we know about the value of x at the y-intercept? It's 0. If I substitute 0 in for these x's, then y is equal to 6. All right, and looking at y equals 20x squared minus 7x, and this one is a little bit tricky. In a sense, it gives us both. I mean, it gives us the y-intercept, and it gives us one of the x-intercepts. And how does that work? Well, if you think about this as having a plus c here, what is it? What is the c? In this case, it's plus 0. And so that would mean that the y-intercept is 0. And so I can write that I got the y-intercept here. And then now what would be the actual point? Well, think, if I substitute into this equation 0 for x, I will get 0 for y. And therefore, my actual point of my y-intercept is going to be 0, 0. And then you should also realize, what is the value of y at the x-intercept? It's 0. So this number is also one of the zeros. Right? And so if this were on a graph, it would look something like this. Now this would go really, really, really far down. Okay, but it would look something like this. And so you would have this point right here, and it's the y-intercept, and it is the one of the zeros. Okay, we can't know based on the equation alone the other zero. All right, so we can move on now to question number 9, which says, for the given parabola, determine all the required information. Could we know the vertex? Yes, we know the vertex. The vertex is right here. The vertex is 0, 3. Could we know the direction? The direction is up. The step pattern, let's look. 1, 3. Oh, and the step pattern is basic. 1, 3, 5. 7, 9, 11, and on. The axis of symmetry, if we divide the parabola in half, it would be a line that goes down like that. And remember, we write in the form x equals. In this case, x is going to be equal to 0. What is the optimal value? So that's the highest or lowest value. In this case, it's the lowest value. It's the highest or lowest y value. In this case, it's the lowest y value, which is 3. And the optimal value is a minimum. And will this parabola have any zeros? The answer is no. And if there were zeros, then we would write them as coordinates. But in this case, there are no zeros, so we can just write none. All right, now question number 10 says a certain parabola has a vertex 2, -7, and the point 3, -5 also happens to be on the parabola. Give formal points on this parabola. Now, not all the points are going to fit on the graph, but we can use it to help us figure out what the point should be. So the first point we're going to put is 2, -7, and 2, -7 is going to be right here. Okay, and this is -7 here, and this is 2. The other point that is on here is here, which is 3 and -5. So if this point 2, -7 is my vertex, then I can see the step pattern that I'm working with right away, because this went up by 2. And so if the basic step pattern is 1, 3, 5, but instead of going up it went up by 2, that means I had to multiply 1 by 2. It means I have to also multiply 3 by 2 and get 6, 5 by 2 and get 10. And this is my step pattern that I'm going to work with here. And so from here, I got to go over 1 and up 6. That's going to take me to this point right here. All right, and then I can erase the steps. But you can see I have now 1 point. What about the other points that I need? Well, I know there's going to be a point here. It's got to have the same y value. It's a symmetrical point, has the same y value, and it's an equal distance from the axis of symmetry. So that's going to be one of the points. And then another point, I'm going to go over 1 and up 6. And that's another symmetrical point that I identified, has the same y value as this point right here, and it's the same distance from the axis of symmetry. So how many points do I now have? Let's write down the ones that I have. The ones that I have so far are 3. That's 1, 2, 3, 4, and 1. And then over here I have 1 and -5. And here I have 0 and 1. And how about the next one? Well, I could find it to either direction. I could go here and here. This has got to go up 10. So I'm at 1, and it's got to go up 10, which means it would be at 11 and 5. 5, 11 is one possibility. And on the other side, it's got to go over 1 this way, so that makes it -1 and 11. And -1 and 11 would be the other possibility. All right, so you don't have to include these weird lines, and we should draw a line to connect these in the shape of a parabola. Okay. All right, so that's how you do this kind of question. The key here is whatever the vertex is, then you draw a step from that. If it's 2, then you know you have to multiply the normal step pattern by 2. If it were 3 here, we'd multiply the normal step pattern by 3, and we would have gotten 3, 9, and 15, and then would have used those to find the next points. Once you find the points on one side of the parabola, you can find the symmetrical points on the other side of the parabola. Number 11 says, draw parabolas based on the information provided. A says draw a parabola that has a vertex of 3, 3 and zeros of 2, 4. So the first thing let's identify the vertex. The vertex is 3, 3. So that's here. This is 3 and this is 3. And then let's find the zeros. Remember, zeros are the same things as x-intercepts. And so what do we know about x-intercepts? At x-intercepts, the y value is always 0. So therefore, the coordinates of this point where the 0 is 2 is going to be 2, 0. And for this one, it's going to be 4, 0. Because at the x-intercepts, the y values are always 0. And so 1 point is going to be here, 1 point is going to be here, and I can now draw my parabola like so. Now we can look at B, which says draw a parabola that has zeros at -5 and -1. -5, 0 and -1, 0, and has a maximum value of 4. So let's first draw the zeros. -5 and 0 is here, -1 and 0 is here. All right, and so now it tells us that it has a maximum value of 4. What that means is that the vertex has a y value that is 4. And the other thing that this maximum tells us is that the parabola opens downward because it's a max. So here we know that the y value is 4, has to be 4. How can we find the x value? Well, very important to note, we do have two symmetrical points. We have two symmetrical points that are on the x-axis. And these points, what we mean by they're symmetrical is that they are going to be an equal distance away from the axis of symmetry, which cuts through here, right? And so they have to have an x value that is right in between these two points of symmetry, and they're going to be right in between all the points of symmetry all the way down the parabola. And so in this case, it's going to have to be along somewhere along here, right? Because this is the halfway point, and we know the y value is 4, and so that puts the point right there. So 1, 2, 3, 4. The point has to be right here because that is the only point that is right in between these two axes of symmetry, these two symmetrical points, sorry, and it has a y value of 4. I could then draw my graph like so. All right, question number 12. It says complete the table of values below, determine whether the relation is linear, quadratic, or neither. And so let's take a look. It says here y is 8, negative 3 and 8, negative 2 and 7. What's the first difference between a 7 and 8? 7 minus 8 gives me negative 1. What's the difference between 4 and 7? That gives me negative 3. What's the difference between negative 1 and 4? That gives me negative 5. What's the difference between negative 8 and negative 1? That gives me negative 7. What's the difference between negative 17 and negative 8? Gives me negative 9. And the difference between negative 28 and negative 17 gives me negative 11. What are the first differences? 2, 2, 2, 2, and 2. Therefore, this relation is quadratic because all the second differences are the same. So we're skipping over question 13. It will not be on your evaluation. But number 14 says the graph below represents the height of a diver versus the time after the diver jumps from the springboard or from a springboard. The height is the diver's vertical distance from the surface of the water in the swimming pool. Answer the following questions based on the information. How high is the springboard from the water? Well, presumably he is jumping. This is where his jump starts, right? Because he's going to go up for a little bit and then he's going to go back down. And so we could say that his springboard is 25 meters above the water. Here is where water is being assumed to be, because as it says, the vertical distance from the surface of the water, right? So this height is height from the water. So then at what time does the diver land in the water? After 3.5 seconds. They've landed because at this point there is 0 meters away from the surface of the water, which means they are at the surface of the water. What is the maximum height the diver reaches? That is going to be right here. That is going to be the maximum point, and it is 30 meters. At what time does the diver reach the maximum height? Well, that's going to be the x value of the vertex, which is 1 second. After leaping from the springboard, for how long is the diver higher than 10 meters from the water? So let's find 10 meters from the water, and it's here. And so for just over 3 seconds. So let's say 3 seconds. Okay, and then a friend tells you that this curve is a parabola. Supposing this is true, give the equation of the axis of symmetry. So we showed that already. This is where it would cut it in half, and so x would be equal to 1. All right, so that covers your practice quiz, and hopefully you understand everything that's in it. If you have any questions, just feel free to shoot me a text, and I can help you as much as I can. Good luck.